Okay, so now we can actually do math that's associated with this and see exactly how many males, females, and couples we're going to have. All right, how's that work? Basically, what we're going to do is we're going to look at this particular case. We've got some reactants, and we've got some products. What are the reactants? All right, what are the reactants in this case? Males and females. And what are the products? Couples. All right, now we can actually apply math to this, and here's how it works. It basically says that you're going to take the concentration of each product. That's too small. We're going to take the concentration of each product over the concentration of each reactant. All right? So in this particular case, and what you have to do, and I'll show you in a minute, we'll get more detailed into it in a minute, but here's the basics of it. So we're going to take the concentration of males, concentration of the products over the concentration of the males times the concentration of the females. All right? Now, in this case, we're going to cheat a little bit. We're just going to say that the gymnasium, we're going to count concentration based on gymnasiums, and we're in one gymnasium. So the concentrations are effectively whatever the number of people is. Because you're saying it's 300 boys per one gymnasium. So we're just cheating a little bit. All right? Now, so when we reached equilibrium, what were the numbers? What were the number of couples?
80.
80.
40.
What were the number of single males?
220.
220. And what were the number of single females?
120.
120. Could somebody give me a calculated answer for that? Anybody? Bueller?
I'm working on it.
80 divided by 220 divided by 120.
80 divided by 100 is 20.
80 divided by 220 divided by 120.
Oh, 0.0303.
0.00303. We'll call that a good number of 6. All right, so what does that say? That says if we presume that this is an average, a normal way in which boys and girls get together and make couples, then if we put greater numbers of either of these reactants in, we would get a similar equilibrium number. Okay? We would get the same KEQ, the same constant for the equilibrium between boys and girls to make couples. It's a little weird, but it works for chemistry. It doesn't really work for people, but it works for chemistry. All right? And here's the deal. When we added all those buff young football players into the mix, this would settle down to reach the same equilibrium. All right? We would be able to mathematically determine how many couples would be formed, how many free males and free females would be there.